Conditional probability. So now we're moving on to the last one here, which is tree diagrams. So we have a bag with 6 green sweets and 4 red sweets, and 2 sweets are selected without replacement. So here's the first selection, so it could be green first or red first, and here are the second selection, so we could have the second one could be green or the second one could be red, hence these numbers here for the second selection and these for the first selection. So the first selection is not conditional on anything, so the probability we select a green sweet first, but there's 6 out of 10, 6/10, and for red it's 4/10. That's straightforward. Now the probability that in our second selection that we select green again, given that the one selected first was green, so a conditional probability, and look at the order of the letters here, the probability of G2, the second one is green, given that we've already selected the first one as green. Yeah, there's an order to these. That event goes first, then this one happens. There were 10 sweets, there's now 9. There were 6 green, we took one out, there's now 5. A conditional probability. And looking at the next branch here, the probability that we select the second sweet as red, given that we've already selected the first sweet as green, is equal to, again there are 9 sweets in the bag now because one was removed. We haven't taken any reds out along this path, so there were 4 red, so it's 4/9. And just to verify, if we add these probabilities together in here, they add up to 1. And likewise down here, so we select the first one as red and then the second one is green, so the probability that the second sweet selected is green, given that the first one selected was red, 6/9, and so on. Now we have to work out the conditional probability that both sweets are red, given that they are both the same color. Again, we start on this side because this event always goes first, and this is the one that we use for the restriction in the sample space. So the same color, so if I go back to the tree diagram and highlight every path through the tree diagram that leads to the same color sweet for the first and second selection. So in here, that's the restriction done. So now I'm going to ignore everything down here, like this. So the probability first that they're both the same color, 6/10 times 5/9, or 4/10 times 3/9. It's either green, green, or red, red. That's all I've got down here. So it's either that path or this one, and the or represents the plus here. So that all goes into the denominator. Now we go on to this side. What's the probability that both sweets are red? So both sweets are red, so 4/10 times 3/9. And then we simplify, and don't be tempted to do this, that's wrong. So 2/7. So this is the method where you take the original tree diagram and we restricted everything to the same color first. So these branches here and these branches down here, the restricted sample space. Work out the probability of the branches that you do have here in the denominator, add them together because you've got those branches or these ones, then work out the probability that you have both which are red, so that's just this path here, put that into the numerator and simplify. That's a good method because it's visual, it's easier to understand. Now the alternative is to use the formula. Now, this is the multiplication rule for conditional probabilities. So event A here here, and here, in this generic formula, represents this same color, same color, same color. And the order of these two doesn't matter. You can write same color on this side or on that side. They're exactly the same. And then event B, that both are red, so that has to go here, and the other space it goes in is here. So we get the probabilities, and these are from the tree diagram. The probability that we have the same color, so we want 2 greens or 2 reds. So we get the probability of 2 greens from here, so 6/10 times 5/9, which is 30 over 90. 2 reds, 4/10 times 3/9, that's 12 over 90. That's where these came from. So it's either 2 greens or, which is a plus, 2 reds. And this here, the probability that they're both red and they're the same color, is just the probability of 2 reds. It's nothing else. We've got that already. And then we can rearrange this to get the same value as before. For further practice, try these questions.